Okay, here we go. Chapter 8, Part 2, talking about soil. It's very, very, very important you know about soil and understand soil. Soil is probably one of the biggest parts, or actually the really important part of this chapter. Soil is very important for a medium, and it has a lot of functions, not just, for roots for plants, but that's one of them. Cycling of nutrients, organisms, filtering water, filtering out pollutants, growing medium for things. Okay, so formation of soil. So there's different factors that determine how soil is formed and what the soil is like in specific areas. What is your parent material? Here in Florida, our parent material is limestone, which is a great buffer, which is why we don't have any pH problems with our soil. It's very neutral, which can be good and bad because some plants like a high pH or a more acidic soil. The climate. What's your weather like? Do you have a freeze and thaw cycle? That actually helps to break up your parent rock. Is your climate sunny and there's photosynthesis all the time year round, like in the tropics? Then that's going to affect your soil because you're not going to have a lot of nutrients in your soil. Your topography is: are you on the side of a mountain? Are you at the valley? Are you flat? That kind of thing. Sloped surfaces are much more likely to have erosion, so they're much more likely to lose dirt. The organisms that are there. Are there lots of worms and bacteria and organisms digging around, adding organic material and stuff to your soil, aerating your soil? Or is it very compacted? And then time. It takes a lot of time. Formation of soil is a very, very, very slow process. So it takes a lot of time to form really good soil. So if you have a brand new volcanic island that's just erupted out of the ocean, just because it's new, the soil's not going to be very good. But if you have a very old forest, like up north, in the Appalachians and stuff like that, you can have some amazingly gorgeous soil. So soil is a process of time. It takes a lot of time to break down all that stuff. And that's part of succession. Remember back to when we talked about succession and how, you can have a fire go through and then everything comes back. It takes time. It takes time to build up that soil, and that's part of that process. Okay. You need to know the layers of soil. You have the O horizon, all the different horizons. You have the O horizon, which is your organic matter. That's your leaf litter, your top stuff right at the top. Then you have your A horizon, which is your topsoil. Dark, rich, black, yummy, full of nutrients, topsoil. Under that, you usually have your B horizon, which is your subsoil. Good, thick, kind of some parent material in there. Lots of sometimes accumulation of nutrients and stuff in this range because they're kind of leached out of the A, so the water carries them down into the B. Your C is your subsoil, and then below that, which is going to be very rocky, and then below that you're going to have your parent material, which is basically your rock. You can have another layer that is not listed here, and that's the E horizon, and that's an alluviation layer. It's a layer that is leached of all nutrients. It's very nutrient poor. It can sometimes occur below the B layer, but sometimes it's between the A and the B. Here in Florida, in an area that has lots of rain, it usually is between A and B. The A, the organic material, is being broken down and decomposing, so there's always nutrients there. But below that, there'll be an alluviation layer, an E horizon. So let's see. Old Aunt Betty or Old Aunt Ethel brings cookies is a good one to remember. But it's pretty easy. It's A, B, C, except for the O and the E. But you got to know your horizons. So your O horizon, this is leaf litter, needles, twigs, animal bodies, stuff on the surface, right on the surface. A horizon is your topsoil. Lots of organic matter. We call it humus, not hummus, humus. Your B horizon is your subsoil. Lots of minerals and stuff, but very little of your organic matter. It's all been decomposed by now. And then your C horizon is your parental material, your subsoil kind of thing. And then, of course, that alluviation layer, which is a leached layer. Okay. Your triangle, your soil triangle. Each side, 3 components to soil: clay, silt, and sand. Clay is the smallest. It's tiny, tiny. It holds, we make cups and stuff out of clay because it will hold water because it's tiny, tiny and will pack together. It's very, very small, as you can see over here. Your silt is a little bit bigger, but still very fine. And then your sand is your largest. And sand can be from quite small to quite large, as you know from going to the beach. If you look at the pyramid here, you have your clay side, your silt side, and then your sand side. And it's based on percentages. So 100% is your soil kind of thing. And you can actually do this, and we'll do this. You can actually shake out soil and see where it ends up. And depending on what percentages it is, depends on what kind of soil it is. Loam is the one. Loam is the best one for agriculture. It's the one you usually want for almost all your agriculture. So loam is the hugely important one. And of course, it's right there in the middle. But you can see there's different types. So if I give you the pyramid and I gave you 3 percentages, you should be able to find them. Although I will tell you that I always find it like, okay, now which line do I follow? But it really doesn't matter, because if you go and follow the lines over where all 3 of the lines meet, that's where you're going to have your things. And we'll practice this. You'll do this. Okay, so different properties of soil. And this is very important that you understand the properties of soil. Porosity is basically how well how do I say this? How well a substance holds water. It has to do with pore space, the space in between them. So if you have big spaces between your stuff, you have high porosity. Clay has very low porosity because there's very little. Clay is very small. It packs together very tightly. There's not much space for water to get through, so it holds water quite well. So it has high porosity. It has lots of spaces. Okay. Where's permeability? Okay. Permeability is how rapidly water goes in there. Porosity and permeability are kind of inversely related to each other. So if you have high porosity, clay has high porosity, lots and lots and lots and lots of tiny little spaces, but they're very tiny. Because they're tiny, it has very low permeability, meaning the water can't go through it. So high porosity, low permeability. Sand, on the other hand, has low porosity because it actually has lots of big spaces. Not as many, but they have big spaces, few big spaces versus lots of little spaces. So it has low porosity, but that means it has high permeability because water will run right through sand. Okay. Cation exchange capacity is the ability for the soil to absorb and release cations, positively charged ions. All your minerals in the soils, all your nitrogen, your phosphorus, your potassium, all those things, they are all in ionic form. So some soils can hang on to those ions, those nutrients, and others can't, and that's your cation exchange. Some types of soil will hang on to negatively charged, while others will hang on to positively charged. Clay has a nice charge to it and can hang on to, and has a better cation exchange. So we'll talk more about that. Your soil bases are your calcium, magnesium, potassium, sodium. So those are your basic or nutrients, and then your acidic ones are your aluminum and your hydrogen. Okay, then you have your biological component. The physical component and some of the testing we'll go over. Later on in the week, we'll go through that stuff. We'll do a lab. Biological properties of soil. Of course, course, there's lots of bacteria, fungus, rodents, that kind of stuff that live in soil, so it's very important. What is our soil made up of? Most of our soil is actually oxygen. Lots and lots of air in our soil, lots of oxygen in our soil, which is very good because, of course, plants need oxygen. We don't want them to drown. So, and you can see all the other things that are in our soil. Minerals in our soil, metals in our soil. Iron, aluminum, copper, lead, zinc, gold. You can see what's there and how much we have of it. All of our metals are non-renewable resources. There's only X amount of gold or whatever in our ground, and once it's out, it's out. So that's why you see all the commercials for recycling your gold, that you don't want selling your gold, because there's no more gold. There's hardly any more gold to go after. So metals are a finite resource. Okay, mining. Moving on into mining. Can I get through mining? Oh, I only have 2 slides on mining. Sure. We'll go over mining. I'll show you some videos on mining because I think mining is very, very important. Surface mining, that is mountaintop removal, strip mining, pit mining, those kind of things. I'll show you some of this. Placer mining occurs in rivers when you pan for gold. So you need to know your different types of mining. We'll talk about mining pollution when we get to pollution, but this will come back up. And then you have subsurface mining. That's when you go down into the hole, you go into the mine. Probably what you kind of think of more when you talk about mine. We'll talk about the effects of contamination and stuff like that. Subsurface mining actually has a lot less damage to the environment because everything's occurring underground, and there's just not as much damage as though, you blow the top of a mountain off. We'll have to watch it. We'll watch a movie on mining because mining's a very big deal and quite scary in some ways. Okay, so we are done with this one. We're done with chapter 8. Hope you enjoyed. If you have any questions, ask me in class. Thank you. Bye.